Today I am going to discuss about nuclear energy, source of power, which is a chapter in first BTech. This is very small chapter. A short answer may be asked from this chapter. Before going to discuss about these energies, we have to develop some basic things about atomic and nuclear physics. Let us consider an atom. This is an atom. This atom consists of a positive protons along with neutral charged neutrons occupied in the small volume. This is the position of protons and neutrons, and this center is known as nucleus. The nucleus surrounded by negative charged moving in different orbitals. So some negative charges are moving around this part, nucleus. The protons and neutrons in this nucleus are collectively referred as nucleons. The protons and neutrons are called nucleons. The atomic nucleus is described by different quantities. First one, atomic number. We have to learn atomic number or charge number is Z. That means atomic number or charge number means here the number of protons in the nucleus or number of electrons in the atom. The neutron number n, the number of neutrons in the nucleus. Mass number A, the number of nucleons in the nucleus. Nucleons means protons and neutrons. The number of neutrons in the nucleus can be termed as n is equal to A minus Z. Now symbolically, X means some element or substance. This is A, this is Z. We know A means all means mass number means number of nucleons. Nucleons means protons and neutrons. Z means atomic number or charge number or the protons count, which is Z. For example, this can be written as 1 H1, H21, H31, like this we can written. This is hydrogen element. This is Z. Z means atomic number. A means the total nucleons number. Next one is density of nucleus. The density of nucleus means the nucleus is compared with a liquid drop. Because due to surface tension, the liquid drop looks like a sphere, which forms a sphere. Here, an atom consists of protons and neutrons and electrons rotating around this nucleus. So this nucleus also imagined as a sphere. This also like a sphere because it was compared with liquid drop. Now the mass of the nucleus m is equal to mp into z, mass of the proton into the atomic number, here plus mass of the neutron, that is A minus Z, number of neutrons into mass of the neutron. Here density means we have to find the mass by volume of the atom. So then m is equal to mp z plus A minus Z into mn. if MP is equal to Mn, then capital M is equal to MPZ plus MPA minus MPZ. These two gets cancelled. Then M is equal to MP into A. Then the mass of the atom nucleus, the mass of the nucleus is equal to MP, mass of the proton into A. A means all. All means protons and neutrons. Nuclear density rho is equal to mass by volume, mass M by volume. We got M is equal to MP into A. Here volume means the volume of the sphere looks like a volume of the atom looks like a sphere, that means 4 by 3 pi r cube. But we know R is equal to R naught into A power 1 by 3. Then rho is equal to MP by 4 by 3 pi R naught cube. Average value of R naught is equal to 1.4 into 10 power minus 15 m, and mass of the proton MP is equal to 1.673 into 10 to the power of minus 27 kg. Therefore, nuclear density rho is equal to 1.45 into 10 power 27 kg per meter cube. By substituting these values in this equation, we'll get this solution. Next one is mass defect. The mass of the nucleus is always less than that the total mass of the individual nucleon. The mass deficiency of nucleus will occur. The deficient of mass nucleus is converted in the form of an energy which will bind nucleons together in a nucleus. The mass defect can be expressed in terms of difference in mass of a nucleons and total mass of the constituents. Suppose that means here the meaning is, suppose this is an atom, this is a nucleus. In this nucleus, this nucleus contains nucleons. Nucleons means, that means the mass of the nucleus is less than that of the individual mass of the nucleons. That means if I measure the mass of this nucleus and if I measure the mass of all the protons and neutrons, then the nucleus mass is greater than that of the nucleus mass. This deficit, this decreasing mass behaves like energy. The defect of mass, that means deficit of mass, behaves like an energy to separate these charged particles. So mass defect delta M is equal to sigma M minus M, where sigma small m means sum of masses of proton and neutrons. Sigma m means. Capital M means mass of the nucleus. Means sigma m is equal to Z into MP plus atomic number into mass of the proton, and A minus Z into Mn, the number of neutrons into mass of the individual neutron. Then sigma m is equal to delta m is equal to ZMP. This is delta m refers the mass defect here. This delta m mass defect plus A minus Z Mn minus mass of the nucleus. This mass defect is different for different nucleus. Different nucleus means it different for different elements. The higher mass defect nuclei has more stable nucleus. That element is more stable. Next concept is binding energy. Binding energy. The total binding energy of a nucleus in the energy required for breaking up nucleus into its constituent protons and placing them at rest at infinite distances from one another. That means this is the energy. That means the deficit energy behaves like a binding energy which breaks the break the nucleus and protons and neutrons and placing at rest in infinite distances from one another. It means the binding energy is the energy equivalent of mass defect. We know Einstein equation E is equal to mc square. Let us consider the mass defect. This is the binding energy. This is delta Eb is equal to delta m means change in mass into c square. C means velocity of light in air. Then delta Eb is equal to, we know, Z into mp. Z means atomic number into mass of the proton. A minus Z, number of neutrons, and mass of the neutron, minus m means mass of the nucleus into c square. The binding energy of the nucleus in MeV, measured in MeV. MeV means million electron volt. Then delta Eb is equal to 931.4 into this value MeV by U. This value by U. U means AMU. Atomic mass units can be indicated as U. Here 1 AMU is equal to 931.5 billion electron volts. So the mass of 1 U is equal to 931.5 million electron volts, where U is equal to atomic mass unit. Next one is nuclear fission. The definition is nuclear fission is the phenomenon to break up the nucleus of heavy atom into two more or equal segments with large amount of energy. This is called nuclear fission. That means breaking up of a big nucleus, a heavy nucleus, into small nuclei. First hand discovered in 1938, that when uranium is bombarded with the thermal neutrons, the uranium nucleus broke up into barium and krypton nuclei of atomic numbers 56 and 36 and liberated 3 neutrons accompanied by tremendous amount of energy. Now this is uranium. The atomic number is 92. When this uranium bombarded with a neutron, it gives a barium of 56 and krypton of 36 plus 3 neutrons. If we add this, plus releases some Q. Q means some quantity of heat. During this reaction, it releases 3 protons at every cycle and releases a heavy heat. The quantity of heat, the maximum quantity of heat is Q. Nuclear fusion. Nuclear fusion is the process of combining two lighter nucleus into heavier nucleus. Since the mass of the final nucleus is less than the rest masses of the original nuclei, there is a loss of mass which gets converted into large amount of energy. The fusion is source of energy for sun and stars. This is nuclear fusion, which is quite opposite to the nuclear fission. In nuclear fission, a heavy nucleus splits up into small nuclei, but here small lighter nuclei are combined and to form a heavy nucleus. Meanwhile, the heavy nucleus mass is less than the rest masses of original nuclei. Then the loss of mass and get converted into large amount of energy. The best example for nuclear fission is sun and stars. So let us see one equation. Suppose when a hydrogen atom is combined with one hydrogen atom, it gives an isotope. This is 1 2 here, and gives some charge plus some frequency of radiation nu, and gives the energy 0.42 million electron volts. This process is called proton-proton cycle. In another reaction, a hydrogen atom combined with a carbon, then 6 plus 1 7, and 12 plus 1 13 gives nitrogen and gives some frequency in the form, the radiation in the form of a certain frequency. This is called carbon cycle. This reaction is called. So these are the examples of nuclear fusion. In this chapter, mass defect, binding energy, nuclear fission, nuclear fusion, and density of atom are the very important topics in this chapter. Short answer may ask from this chapter. You prepare well. Thank you.